Hello everyone, we will continue our lecture on interpretive structural model. In the last lecture we saw what is interpretive structural model or ISM. Then we saw why we should use ISM and what are the benefits of this method as compared to other MCDM methods. We also saw and explained steps in ISM one by one. In this lecture we will see we will see an example for supplier selection using interpretive structural model to have a clear idea on this method or to know how ISM works. The first one is identifying the factors. So while selecting a supplier, we will identify the factors such as cost, quality, reliability, delivery time, financial stability and geographical location. So we have considered only 6 factors here. There can be other factors also, but just to provide an easy understanding and for a simple example, we have considered only 6 factors. And these factors are also not related to any case study or real data. This is just our logic and to just show an example for a simple and clear understanding of ISM method. The step 2 is developing a context relationship. So to develop the context relationship, we have to write the questionnaire. So the questionnaires will be like a pairwise comparison. So the questions will be like this. The cost will influence quality, cost will influence reliability, cost will influence delivery time, cost will influence financial stability, cost will influence geographic location, and then quality will influence cost and so on. So there will be as there are 6 factors, there will be 6 into 5, 30 number of questions like this to get the pairwise comparison. These questions are given to the experts and we will have an yes or no answer. So for example, for cost will influence quality, the answer will be yes. So this is also just an example. We didn't consider any expert opinion, or we didn't consider any real data or case study. So next is constructing a self-interaction matrix. So we can see that the relationship between each factor here. So for example, we can see the cost is directly influencing quality. It is yes, and quality will influence cost, and hence it is also S. So it means that both of them directly influence each other, and the relationship in the self interaction matrix should be X. So we can see here self interaction matrix, the relation between cost and quality is X. So we can say the relationship between cost and geographical location is A. It means that geographical location directly influences cost of product, but cost of product does not directly influence geographical location. Then the next example we can see the cost of product and financial stability, the relationship is V. It means that cost of product directly influences financial stability, but financial stability does not influence cost. Also, the relationship between cost of product and delivery time is O, means cost of product does not directly influence delivery time, and also delivery time also does not influence cost. So both of them, both the factors are do not influence each other. And we can also see the diagonal elements are X because if there are same factors influence with itself. So we will see one more example and we will go to the next step. So the relationship between reliability and financial stability, it is A. It means that reliability does not influence financial stability, but financial stability directly influence reliability. So this is how the the self interaction matrix is formed by knowing the relationship and by knowing the answers from the experts. The next step is developing a reachability matrix. So depending upon the relationship in the self interaction matrix, we have to develop a reachability matrix. If we can see in the self interaction matrix, so if we can see in the self interaction matrix, the relationship between cost of product and geographical location is A. It means that cost of product does not directly influence geographical location. Hence, cost of product and geographical location, the value will be 0. At the same time, geographical location will directly influence cost of product because the relationship is A. So, as we can see here, geographical location directly influence cost. Next example, cost of product and financial stability, it is V. So, it will be cost of product directly influence financial stability, but financial stability does not directly influence cost of product. Hence, so cost of product to financial stability will be 1, as financial stability does not directly influence cost, it will be 0. The next example is cost of product and delivery time. As the relationship is O, cost of product does not influence delivery time. Also, delivery time does not influence cost. Hence, in reachability matrix, it will be cost of product and delivery time, it will be 0. Also, delivery time to cost will also be 0, because the relationship is O, both of them does not influence each other. Next example, we can take cost and maybe, so next example, we can take cost of product and quality. So, cost directly influence quality, and also quality influence cost of product. So, both of them directly influence each other. The cost to product, cost to quality is 1, and quality to cost is also 1. So, this is how a reachability matrix is developed, and we have to fill all the other cells by knowing the relationship in the self interaction matrix. We will see one more example. So, we can take reliability and delivery time, it is V. Hence, reliability to delivery time will be 1, but delivery time to reliability will be 0. So, reliability to delivery time, the influence will be 1, but delivery time to reliability, it will be 0. So, this is how a reachability matrix is developed, but this reachability matrix shows only direct relationship between the factors. But to reach the final reachability matrix, we have to consider the transitivity rule. So, this is a reachability matrix that after considering the transitivity rule. So, as we said, transitivity rule means if A is influencing B, B is influencing C, then A influences C. So, we can see here the relationship between reliability and cost of product. So, reliability and cost of product. So, reliability does not directly influence cost, but reliability directly influence quality, quality influence cost. So, reliability also influences cost. So, the cell in the reliability to cost will be 1. Next, reliability to financial stability. So, reliability will not directly influence financial stability, but it will influence quality. So, reliability influence quality, quality influence cost, cost influence financial stability. Hence, reliability will influence financial stability. So, this will also become 1. Next example we can see geographical location and quality. So, geographical location does not influence quality, but geographical location influence cost, and cost influence quality. So, there is a relationship between geographical location and quality. Hence, geographical location influence quality, and this cell can also become 1. Then, geographical location and financial stability. So, geographical location does not directly influence financial stability, but it influence cost, and cost influence financial stability. So, geographical location will influence financial stability. Here also we will have 1. So, we can see all the 4 cells which are blue in color are getting the values of 1 after considering the transitivity rule. And then the next step is to form a Micmac analysis. To form a Micmac analysis, we should know the driving and depending power of each factor. So, as we said, driving power is the sum of the rows of the factors. So, cost of product. So, we can see the driving power is 1, 2, 3, and quality it will be the driving power is 2, reliability plus 2 plus 3 plus 4 plus 5 is 5, and delivery time it is 1. The driving power of financial stability is also 1. Geographical location it will be 5, and dependence power we can say the cost of product will be, dependence power is the sum of the columns. So, cost of product it is 4, and quality the dependence power will be also 4, reliability it will be 1, delivery time 3, and financial stability it is 4, geographical location it is 1. So, these are the dependent power and driving powers. So, after knowing the dependent power and driving power, we have to plot for each factor. So, if we take the cost, we have the driving power as cost, we have the driving power as 3 and dependence power as 4. So, we have to plot 4 comma 3. So, cost will be at 4 comma 3. So, in quality, the dependent power will be 2 and driving power will be 2 and depending power will be 4. So, we have to plot a point for quality at 4 comma 2. Financial stability, you can see the driving power is 1 and dependent power is 4. So, we have to plot a point at 4 comma 1 for financial stability, and delivery time, it will be 3 comma 1, 3 comma 1, and for reliability and location, the depending power is 1 and driving power is 5, hence we will plot at 1 comma 5. So, based on this we will plot for all the factors, and we will divide this rectangle. So, this graph is called driving and dependent chart, and we will divide the driving and dependent chart based on these two lines. So, we can see one horizontal line and one vertical line is dividing this rectangle. So, let us see how these lines are drawn. So, in case of dependent power, we have to sum up the dependent power 4, 8, 9, 12. So, it is 17. Sum of the depending power is 17 and we have to divide it by the number of factors, that is 6. So, it will be around 2.66, and we have to plot a line at 2.66, this vertical line. And for driving, and same we have to repeat for driving power. So, for driving power, we will add all the driving powers, 5, 17. So, again 17, and we have to divide it by 6, which is around 2.3 or something around. So, we will have a point, we will draw a line at 2.6 and we will have driving. So, these two lines are drawn and it is dividing the rectangle into 4 parts, and based on this division we can classify the factors into dependent, independent, linking and autonomous. So, in this example we can see that dependent factors are delivery time, quality and financial stability. So, these factors are more dependent on others, and cost is a linking factor. So, it means that cost acts as a linking variable between the factors. So, it is the main reason, these linking factors are the main reason for the indirect relationship between the factors. So, independent means these are the factors that do not depend upon the other factors, and reliability and location in this example are independent factors. Also, in this example we do not have any autonomous factor. So, this is how we can classify this is how ISM can help us to classify the factors into dependent, autonomous, linking and independent factors. And next step is partitioning the matrix, reachability matrix. So, for partitioning reachability matrix, as we seen, we have to find the reachability, antecedence and intersection, then we will find the level. So, for cost of product, we can see that reachability. So, reachability means factors which are influenced by the factor under consideration. Here the factor under consideration is cost of product. So, reachability will be when we see the final reachability matrix. So, when we see the final reachability matrix, let us give the numbers. So, 6. So, when we see the final reachability matrix for cost of product, the factors that are influenced by the cost of product are 1, 2 and 5. So, we can see 1, 2 and 5. The antecedents are the factors that influence the cost of product. So, the factors that are influencing cost of products are 1, 2, 3 and 6. So, 1, 2, 3 and 6, and intersection are the common factors and reachability and antecedents, and common factors here are 1, 2. So, 1 and 2 are the common factors, so it will be included in the intersection. We next take the second factor, which is quality. So, we can see the reachability is, for quality it is 1 and 2 are influenced by quality, and factors 1, 2, 3 and 6 are influencing the quality. So, 1, 2 will be in the reachability, 1, 2, 3 and 6 will be in antecedents, and intersection we have 1 and 2 because these are common in reachability and antecedents. So, in reliability, if we can see, the factors that are influenced by the reliability are 1, 2, 3, 4 and 5, and factors that influence reliability are reliability itself, that is 3. So, we will take 1, 2, 3, 4, 5 and 3. So, delivery time, you can say that factors that are influenced by delivery time is delivery time itself. So, 4, and factors that are influencing delivery time are 3, 4 and 6. So, we will check once more. Factors that are influenced by delivery time is delivery time itself, that is 4. Factors that is influencing delivery time are 3, 4 and 6. So, 4, 3, 4, 6 and the intersection will be 4, as 4 is common in both reachability and antecedents. Similarly, for financial stability it will be 5 and 1, 3, 5 and 6. So, 5 in reachability, 1, 3, 5 and 6 in antecedents, and intersection it will be 5. So, last, geographical location. So, the factors which are influenced by geographical location are cost of product 1, quality 2 and delivery time, financial stability and geographical location, that is 1, 2, 4, 5 and 6. 1, 2, 4, 5 and 6, and factors that are influencing geographical location are geographical location itself. So, it is just 6. So, it is 6. So, the intersection will be 6. Then, after finding the reachability, antecedents and intersection, we have to find the level of each factor. So, that we can give the level if the reachability and intersection are same. So, if we take the first factor, cost of product, the reachability is 1, 2, 5 and intersection is 1, 2. Both are not same, and hence we will skip this factor. For quality, the reachability will be 1, 2 and intersection is 1, 2, both are same, hence we are giving a first level. So, then third one, reliability, the reachability and intersection are different, so we are skipping this. In delivery time, the reachability is 4 and intersection is also 4. So, we are giving the same level. So, in one iteration there will be only one level. So, as the delivery time is getting the level in this iteration, it will be also given level 1. Similarly, financial stability, the reachability is 5 and intersection is 5. So, there will be a level as both are same. So, it will be also given level 1. So, as this is the first iteration, we are giving level 1 to the factors which are getting the levels. So, geographical location, the reachability and intersection are not same. So, they will be skipping. So, we can see from this iteration, factor 2, factor 4 and factor 5 are getting a level, and these are level 1 factors. So, for the next iteration, we will not consider these factors and we will remove these factors and we will go for next iteration. So, as we can see, we removed the factors 2, 4 and 5 as they have already got the levels. So, now again we will repeat the same procedure. So, for cost of product, the reachability is 1, intersection is 1. So, both are same, they are getting the cost of product is getting a level. Reliability, the reachability is 1, 3, intersection is 3. So, it is not getting any level, we will skip this. Geographical location, again 1, 6 is the reachability, intersection is 6, both are not same. So, we will skip this. So only cost of product is getting a level in iteration 2, and hence it will be in level 2. The next iteration we will remove the cost of quality because cost of product because it already got a level, and we will also remove 2, 4 and 5 because they also got a level at first iteration. So the remaining is only 3 and 6. So we will check for reliability, that is the third factor. The reachability is 3, intersection is 3, hence there will be a level because both are same, there will be a level, and at the third iteration we are giving level 3. Geographical location also gets a level in the third iteration because both reachability and intersection are same, and so it is in level 3. And then after taking all the levels, we will have the digraph. So in digraph, we will the factors which we are the factor which are getting the levels at the last will be will come at the bottom. So the factor that comes at the last belongs to level 3, and so it's coming at the bottom. Factors 3 and 6 are getting the levels at the last iteration, and they are in level 3 and they will come at the bottom. And then factor 1 will come in the next level, and then 2, 4 and 5 will come in the level 1 because they got the levels their levels in the first level. So this is digraph. So this digraph, we have to convert this digraph into an ISM based model. So in ISM based model, we will replace the numbers in the digraph to the names of the factor. So we can see the reliability and geographic location are in the bottommost, and cost of product in the middle, quality, delivery time and financial stability at the top. So we can see that geographical location and reliability are influencing the cost of product. Also, cost of product is influencing the financial stability, delivery time and quality. And now we have to check the thumb rule, which we have seen that if the factors are in the same level, they should not have a one-way link. So either they should have a two-way link or they should not have a link. It means that the reliability and geographical location are in the same level. So reliability and geography should be are in the same level, or so they should their relationship should be either O or X. It should not be V or A. So we will check the relationship between reliability and geographical location in the self interaction matrix. So reliability and geographical location, it is O. Hence there is no one way link between reliability and geographical location. The next level is cost of product. So cost of product, there is only one factor, it influences itself. So the relationship is X and it's not V or A. The next level is level 1, that is quality, delivery time and financial stability. So as there are 3 factors, we have to check the relationship between all the 3. So so the quality and quality, delivery time and financial stability. So quality, delivery time and financial stability. So we can see the relationship between quality and delivery time. It is in the self interaction matrix. We have to check in self interaction matrix. So if we see quality and delivery time, relation is O. Hence there is no one way link. And then quality and financial stability, it is again O. So there is no one way link. Next we will check the relationship between delivery time and financial stability. Delivery time and financial stability is also O, and there is no one way link. So level 1 also satisfies this thumb rule. So all the levels are satisfying the thumb rule. Hence, so we can stop the ISM model. If they are not, if they are having a if the factors in a level, the same level, are having a one way link, that is having a relationship A or V, then we should repeat the procedures. We have to reconsider the factors that we considered, and we have to reconsider the expert's opinion also, and then we have to repeat the procedure. So summary, so thumb rule satisfied, we have checked. So from this diagram we can conclude that quality, financial stability and delivery time are the least influencing factors. That means the factors that are coming at the top level are least influencing factors. On the middle are the linking factors. So, here cost will be the linking factor in this example. Also, reliability and geographical location are the most influencing factors. These are the factors that influence others. So, by knowing this, we can by examining this diagram, we can determine which supplier to choose. So, we can have we have a hierarchical links between the factors, and we know which factor is more important, which factor is linking the factors, and which factors are dependent, etc. So, we can consider this diagram to select the supplier. So, this is how a supplier is selected with the help of ISM method. So, limitations of this method is it is a subjective method. As we are getting opinions from the experts, the expert opinions will be subjective. So, that is a small limitation in the ISM method. And complexity increases with the number of factors. So, we have considered only 6 factors. For 6 factors, we took some time, but if the number of factors are 20 to 25, the complexity will increase, because it will be it is also very difficult to find the transitivity between the factors. Sensitivity to input parameters. So, a small change in the input parameters or any input parameters will change the result significantly, and less affecting factors are not considered. So, here only important factors are considered to reduce the complexity. So, if less affecting factors are considered, the number of factors will increase and the complexity will also increase. And difficulty in validation. As this is not a statistical model, it is very difficult to validate the results which we have obtained from the interpreted structural model. So, this is the interpreted structural model. Thank you.